Hello everybody, I welcome you all in 14th session of your Physics Paper 1 syllabus. In last session, we have seen the concepts regarding a branch of physics, that is acoustics. And we have seen that in acoustics and even in day-to-day life, the transducers play a very important role. So in this session, we will see the things related with a transducer. A transducer is nothing but a device that converts one form of energy to another form. Or it is also defined as a device that converts non-electrical physical quantity into electrical quantity, which is measurable, such as voltage, current, capacitance, etc. When we look at the structure of a transducer, for any kind of transducer, it contains two main parts, that is a sensing unit and a transduction unit. A sensing unit is a unit that converts a sensing unit sends the input quantity to be measured and send it to a transduction unit. The transduction unit converts that input signal into the output signals which are measurable. So a transducer mainly contains two parts, that is a sensing part and a transduction part. Now there are various ways by which we can classify a transducer into different types. So the classification will be based on the source of energy. It will be based on quantity to be measured. It is based on the physical effect or what is going to be varying during the process of transduction. This also cause the transducers to be classified into various classes. Transducers are classified according to principle of operation also. Transducers are also classified as either analog or digital transducers. One more branch that I haven't included here, the transducers are also classified as primary or secondary transducer or transducer or inverse transducer. So there are various ways by which we can classify transducer into various classes. So depending on this classification scheme, a transducer is of a variety of types. There are huge number of classes of transducer. So let us see one by one. The main classification scheme that is considered by speaking about the transducer is whether the transducer is active transducer or passive transducer. An active transducer, also known as the self-generating type transducer, is the transducer that doesn't require any external source of power to convert input signal to output signal. Rather, it has the ability to generate the electrical voltage or current as its output without using any external source. So, these transducers draw the energy needed for their operation from the measuring system itself. This transducer, we call it as the active transducer. For example, thermocouple is an active transducer. Another class which depends on whether external energy is required or not is the passive transducer. These transducers are also known as externally powered transducers. These transducers convert input signal into output signal with the help of some auxiliary source, some another source. So, These passive transducers induces variation in the parameters associated with the electrical circuit with the variation in the applied signal. For example, thermistor is a passive transducer. This is one classification scheme. Let us see what are the examples of passive transducers. There are many passive transducers, and here I am classifying this passive transducer again in few classes that depends on which parameter is changing while the transduction process is going on. So, in case of this class, resistance passive transducer, it is the resistance that varies when input signal is going to be converted into output signal. There are various examples like strain gauge, thermometer, hygrometer, hot wire meter, photoconductive cell, that is light dependent resistance, thermistor, potentiometer. These are the examples of passive transducer, in which it is the resistance that varies while the process of transduction takes place. Another class of passive transducers is the one in which capacitance varies. So, the examples in which the capacitance of the system varies when one convert input signal to output signal is like variable capacitance pressure gauge or gauge, which is used to measure displacement or applied pressure. The capacitor microphone, which is a very well-known device, is again a passive transducer. It is the dielectric gauge, which is again a passive transducer. Another class of passive transducer is the one that uses inductance as a variable, that is, while converting input signal to output signal, inductance of system changes either in the form of self-inductance, mutual inductance, or in the form of eddy currents. So, these are the various examples in which inductance of the system varies while converting input signal to obtain the desired output. Apart from this resistance, capacitance or inductance type of passive transducers, there are few more passive transducers in which voltage or current changes like Hall effect pickup, ionization chamber, photomultiplier tube, photoemissive cells. These are again the examples of passive transducers. Let us come to the class of active transducers. The transducers, which are also known as the self-generating transducers. These transducers doesn't require any auxiliary source or external power supply for the conversion of input signal to output signal. The examples of active transducers are thermocouples, moving coil generators, piezoelectric pickup that we have to study in detail in next lectures, tacho generator, diaphragm, Burden tubes, photovoltaic cells. These are the examples of active transducers. So, here are the differences between an active transducer and a passive transducer. The main thing that you have to focus here, apart from the definition, is that the design or construction of active transducer is simple one, but the construction of passive transducer is quite complex. The active transducer have a low resolution power, whereas passive transducers have high resolution. As we have said, active transducer doesn't require any external energy source for the conversion, whereas in case of passive transducers, external energy is needed. the signal coming from output signal coming from the active transducer is so weak that one need a further amplification of that output signal. Whereas in case of passive transducers, the output signal is much more better, that it doesn't require any further amplification process. So these are the examples. Thermocouple is an active transducer. Thermistor is a passive transducer. So these are the few differences of active and passive transducers. Apart from this very important classification scheme of transducer, transducers are also classified as analog transducer or digital transducer. As the name itself suggests what is going on in the transducer. In case of analog transducer, the output what we will obtain is a continuous function of time, whereas in case of digital transducers, the output is in the form of pulses. So the digital transducers are very well used and very sensible transducers that are widely used in the world. It provides absolute accuracy and discrimination and are less sensitive to the external noise. It gives a much more simplified data presentation. Like the manipulation of data, acquisition of data is quite simpler one in case of digital transducers as compared to the analog transducers. Here are the examples of this type of transducers. Another classification scheme of transducers depend on whether the input signal is directly sensed by the transducer or not. A primary transducer is a transducer in which the input signal is directly sensed by the transducer and the input physical quantity is converted into the output electrical signal directly. This type of transducer we call it as the primary transducers. Whereas in case of secondary transducer, the physical quantity to be measured is first converted into some another form, and this converted form is then used to generate the output signal. So this is the way by which a transducer is classified as a primary transducer or a secondary transducer. Another classification scheme of transducer is like transducers and inverse transducers. As I have said before, a transducer converts non-electrical quantity such as sound, pressure, force to some electrical quantity such as voltage, temperature, current, etc. Whereas inverse transducers convert electrical quantity to some non-electrical quantity. This is the way how one can classify a transducer and an inverse transducer. So these are the various ways by which we can classify transducers into various classes. Now, when we say that a transducer is a good transducer, which are the parameters that decide the goodness of the transducer? So here is the list. A good transducer should have high input impedance and low output impedance. A transducer should have high input impedance and low output impedance. It should have a good resolution over entire selected range. So, a good transducer should have high input impedance and low output impedance. It should have a good resolution over entire selected range. A transducer must be highly sensitive to desired signal, and at the same time it should be insensitive to other signals. A good transducer should be small in size and low in weight. It should be able to withstand various pressure, vibrations and shocks. It should have a high degree of accuracy and sensitivity, and a good transducer should be able to work in any corrosive environment. So these are the few parameters which decide whether a transducer is good transducer or not. Now let us see what are the characteristics of a transducer. The very first characteristic which is considered while selecting a transducer is an accuracy. Accuracy is the closeness of transducer's output to the true value of measured quantity. So a transducer should be highly accurate one. It is the largest expected error between actual and ideal output signal. The sensitivity of electrical transducer is defined as the electrical output obtained per unit change in the physical parameter of input quantity. This is the very important characteristic of a transducer. Next one is the dynamic range over which the transducer could operate and give a proper result. For a transducer, the operating range should be wide one so that it can be used over a wide range of measurements. The transducer should be mechanically rugged to withstand the overloads. It should have the overload protection. Repeatability of transducer. Suppose I have taken a set of observation with a transducer. I have given some input and measured the output. Now, if I repeat the same thing again and again, then ideally the transducer should generate the same output each and every time. What we call it as the repeatability of transducer. Noise is another parameter. Now, for each and every transducer, the internal circuitry built its own noise, and that noise will get added to the output signal. So, when we consider a transducer as a good transducer, what we expect that this noise generated by the internal circuitry should be as much low as possible. So, noise is again a parameter that decide whether the transducer is good or bad. Linearity of transducer. What is mean by linearity? It is the output of transducer in comparison to the input signals. So what we expect that input and output quantities should be linear to each other. So we can say there should be a linear input output characteristic. What is mean by hysteresis of a transducer? So hysteresis is defined as the magnitude of error caused in the output for a given value of input when this value is approached from opposite direction. Means suppose I have taken reading from 1 to 10. If I again come from 10 to 1, the output should be same ideally, but it is not happened. The output will change slightly. What we call it as the hysteresis. The resolution of transducer is defined as the smallest increment of measured value that can be detected with certainty in that instrument. So what we expect? A good transducer should have high resolution. And another parameter associated with the transducer is the frequency response. The frequency response should be uniform throughout the whole range of audio frequency. This is what we expect from a good transducer. So these are few characteristics of a transducer. If you have any question, You can comment here or you can ask me anytime. Thank you. Have a nice day.